Hi, welcome to eCHO. This is episode 50 of the eBPF and Cilium office hours. So as always, if you're watching live, do say hello in the comments, and we always love to get your questions and know where you're watching us from. So yeah, say hello if you are live. And in a few minutes time, we will be talking about BTFGen with Mauricio Vásquez from Microsoft. But before we do that, let's look at a few headlines from the last week or so, some of the interesting articles and YouTube videos that we've found about eBPF in the last week or so. Hi to Russell, regular viewer. Nice to see you, Russell. You're the first one to post hello, so hi. First headline that we have today is it's called Honey Potion, and this is about writing eBPF programs using the Elixir programming language. Personally, that's a language that I am not familiar with. I mean, I've heard of it, but that's all. I've never tried writing any. Apparently, this is going to translate Elixir into C, and then C can be compiled into the eBPF bytecode. So if anybody gives that a try, it would be really interesting to hear how you get on with that. The next headline that we've picked up here, this is a video from PlatformCon 22. And in this video, it is the team from Meltwater talking about migrating to Cilium. So that's a good real life story of people doing a migration to Cilium. Another hello message. Hi from Francesco. Thanks for watching, Francesco. Good to see you. The next headline we've got, this is an interesting article. This is from Alex McKenzie, who is a VC at Tapestry. And he does dive into what eBPF is. He actually walks through one of the kind of getting started Hello World programs that I originally wrote. I was kind of amused to see myself referenced in this when I read this article. But it's interesting to hear that, investors are excited about what's happening in the world of eBPF. He does actually say if you're working in this world, he's interested to hear from people. So we're clearly seeing attention, not just on the technical side, but also on the business side and the kind of money-making side. So I think people are recognizing the power of eBPF and the importance of eBPF. Going to a more technical article, this is from Red Hat, and it's diving into how you can measure the performance of BPF programs. It's actually pretty, goes down pretty detailed about how some different approaches that they've taken to trying to measure how long it's taking to execute BPF programs and how much difference or how much overhead there is by adding BPF. I mean, I think we all know that it's a pretty efficient and high performance way to instrument your code, but you still have to measure what overhead that is. So this is a pretty interesting article. And the last item that we've picked up for this week is a nice article on the new stack about Tetragon, which is part of the Cilium project and is an eBPF-based observability platform, security observability platform even. I think this was actually a pretty nice summary of what Tetragon is in this article. So thanks to Stephen for writing such a great write-up. So those are the headlines that we identified this week. As always, if you have written or created some video or created any kind of content about eBPF or Cilium and you think it would be interesting to viewers of eCHO, then do get us in touch with us. You can find us on the Cilium and eBPF Slack. There's an eBPF news channel there. And that's a great place to let us know about new things you're working on, articles you've written. Always great to hear from what you're doing. Okay, so I think at this point it would be a great time to bring into the show Mauricio. So, hi, Mauricio. Thanks for joining us today.
Hi, Liz. Thank you so much for the invitation. I'm so happy to be here.
Great to have you on the eCHO show. So, today we're going to be talking about BTFGen that you've been working on, I believe.
Yeah, that's right.
So let's start with the background, and you could maybe tell us what is the problem that BTFGen is solving?
Yeah, sure. So, as we all know, we have different applications where we are using eBPF to do amazing things like security, observability, also networking. And we, as developers, we would like to run those different applications in many different platforms. I mean, in many different Linux distributions, different versions of the kernel, and so on. Unfortunately, for eBPF, this is not so easy. Uh, there are some problems regarding portability of eBPF programs. So what usually happens is that if you compile an eBPF program on your machine and then you try to run that program on a different machine, this is not going to work. So yeah, we have a project that is called Inspector Gadget at Microsoft, and we were looking at different possibilities about how to be able to run those tools in different kernel versions. And we hit this problem. So actually, the technical issue is that the kernel structures of the layout of the kernel structure changes from one version to the other. So when we have an eBPF program, we want to access information from the kernel. We want to get the PID of a process. We want to get the mount namespace. We want to get different information about what is going on in the kernel. And to get that information, we need to access internal data of the kernel. And those structures are internal to the kernel. So those structures are not part of any public API. Those are internal structures of the kernel. So there is no any guarantee about the API or ABI compatibility of those. So yeah, it can happen from one version to another. The layout of the structure changes because there is a new member. The types of the member could change and so on. So yeah, what it means for us is that this is not possible to just compile one program in one machine and ship the compiled program to different machines. This is something that has traditionally been solved by BCC by shipping the source code of the eBPF program and compiling those on the different target machines. So in each target machine, we have the Linux kernels headers with the right representation of the structures of that machine. So when we compile, the eBPF program will be using the right representation of the kernel structure and we are able to access the members of the structures at the right offset. Of course, this is not an ideal solution because we have to cheat the source code, we have to cheat the compiler because we need to compile there. The compiler is pretty big. Also, compiling requires some time. So yeah, there are some disadvantages there. And yeah, we were on a process of porting Inspector Gadget from that approach to use a newer approach that is called compile once, run everywhere. So this is something that was created by the Facebook folks, something like, I will say 4 years ago, I think. And the idea is that we can compile a program on a machine, an eBPF program on a machine, and then we can ship that program to a different machine. But there is a process that before loading the program into the kernel of the target machine, there is a patching process that updates the offsets that this program is trying to access to be able to, to access the members at the right offset according to the information that we have on the target machine. Actually, yeah, I have a slide here. It could clarify this. Let me share my screen. Please let me know if you are able to see my screen.
Yeah, that seems to have come through great. Yeah.
Okay, so yeah, this is what happens with core. So we have our compiled eBPF program. We have something that is called BTF. This is, in few words, this is some information that the kernel provides regarding all the data types of the kernel. So in that information, we have the layout of the structures, the type of the members of the structures, and a lot of information. And this information is used by the loader library to perform something like a matching algorithm. So the loader library is able to understand, okay, we have this eBPF program that is trying to access this member, but this member on this specific machine is in this offset. So we update the assembly instructions of the program to access the member at the right offset on the target machine.
So we might say we're looking at this data structure. If you want to access this particular field name, it's so many bytes offset from the structure, and that number of bytes is going to depend on the target machine.
Yeah. So when there is a lot on or a store instruction in the assembly, there is a constant. This is the, this is the offset within the structure, and this is changed by the loader library using this BTF information.
Cool. So that information, the BTF information, which I think is BPF type format, right?
Yeah, that's right.
Yeah. So where does that come from?
Yeah, so this is something that is exposed usually by the kernel. So there is a configuration flag that we can enable to expose that information in the kernel. But yeah, the problem with that flag is that this is not available on all the Linux kernel distributions, or whether it was not enabled, because nowadays I will say that this is almost enabled everywhere. So there are some kernel distributions that don't provide you this information. And this is the problem that we were having with Inspector Gadget. So I was telling everyone in our team, okay, let's use core. Core is great. We can ship the compiled programs. But there was always some pushback, and they were saying, okay, but BTF is not available on all the machines. This is not going to work everywhere. So there are some users that will have some problems to run those tools. So yeah, this is the reason why we started looking at different possibilities about how to run eBPF programs using core in machines that don't provide BTF information.
All right. So I guess that takes us to something called BTFHub, which my ex-colleagues at eCHO, I think, originally put together, right?
Yeah. So when I was looking for a solution for this problem, while reading different messages on the Cillian Slack channel, I saw something like, hey, we have BTFHub. Actually, I can share the repo here. So this is the repo for BTFHub. So what this project does is that it provides BTF information for kernels that are not compiled with BTF support. So let's say that if you are running an old kernel and you don't have BTF information there, you can go to this repository, and then you'll be able to find the BTF information for those kernels. For instance, we have here Ubuntu, we have different versions, and you can see that for each one of the released kernel versions of that specific distribution, we have a BTF file.
And I guess if you are running a particular distribution of Linux, and you've got a particular version of the kernel that doesn't have that BTF information, so long as somebody else has built the same version of the kernel with that information, that's going to be compatible with your machine, right? And that's what's being stored in this BTFHub.
Yes, if you are running the same distribution, the same version, of course, the same architecture, and the exact same kernel version, the BTF information is just the same for the different machines. So that's the reason why we can get the information from an external source that is going to, and that's going to work fine. Yeah. Actually, yeah, just to tell a little bit more about the story of BTFGen. So yeah, we were looking at different ways about how to run those programs in these machines without BTF information. And at the beginning, I was trying to make different experiments, looking for different solutions. So at the same time, there was somebody from our team that was working on something that is called Sysmon. So this is like a porting of the Sysmon Windows tool for Linux. Yeah. And they were having the same problem. So they want to run this tool on different machines without using BTF. And yeah, they were experimenting with a similar approach. So they have something like a file, a JSON file where they store all the offsets of the different members that they access on their programs. So yeah, I took some inspiration from there, and I say, okay, maybe we can use this idea, but what about if we base on already existing things like core, like BTF, and so on? So yeah, at the beginning, I just tried to combine different ideas, and I realized, okay, there is an opportunity there. Let's use BTF, let's use core, and let's implement BTFGen. But yeah, I think I go a little bit ahead on the history of this program. I'm just so
I think I
excited
remember
about.
Kevin Sheldrake doing a talk about the approach they took for Sysmon for Linux.
Yeah, that's right. Actually, yeah, we internally, I already know about this project before that talk, but yeah, there is a talk explaining this approach to be able to run those programs in different kernel versions.
Yeah. Okay, so we set Sysmon for Linux aside and we go back to thinking about BTF files that you could download from BTFHub. What's the problem with that? What are the limitations of those BTF files?
Okay, so let's do something first. I have prepared a small demonstration. I can show you how we can use BTFHub to run an application in a machine where we don't have a BTF information, right? So I have this small example. This is based on the libbpf-bootstrap repository, just in case if you are not aware and you want to learn more about libbpf, or better, if you want to start using libbpf, this is a great source. So there are some simple examples there. This is just everything is just ready to use. You just need to run a make command, and this is going to compile everything for you. So actually, I like to use the repo when I have to run like a simple example. So instead of creating everything from scratch, I just clone the repo, make some small modifications, and reuse all the logic that we have there. So yeah, we have this minimal BPF program. This is based on the repo. I just changed a little bit the way to get the PID. So yeah, the purpose of these programs is only to show when the enter syscall is triggered for a given PID. So in order to do that, I need to check the PID of the process that triggered the syscall. So yeah, in order to do that, we get the structure, the Linux kernel task structure, and we use this macro to read the PID. So this is the way how we use BPF core to tell the compiler, hey, we want to access the PID member on the task structure. Please save some extra information so at runtime, the libbpf library is able to patch the program. So yeah, as you can see, this is a very simple program. We are just getting the PID and we are printing the PID that triggered this program. On the user space part, we have like the general way we use to load the programs with libbpf. So let's just going to the most important part. We have an open function to load the skeleton. We have another function to load the programs into the kernel. And then we have a function to attach those programs to the kernel, I mean, to the different hook points on the kernel. And yeah, in this specific example, we are tracing the right syscall. So just to trigger the program, we are going to print something to our terminal. Right, so let me switch to that program. Okay, I'm just compiling the program. And okay, this is taking a bit longer than expected. That's fine. So if I try to run the program on my machine, this is not working. We get an error because somebody says, okay, there is no, actually the right message is this one. There is no BTF information available. So okay. Great.
So is that looking in the sort of well-known place?
Yeah, that's right.
For the BTF file in the kernel.
Yeah, so I'm running this version of the kernel, and this is the distribution that I'm running. This is an Ubuntu system. And if we look at the configuration flags of this machine, this flag, the ones that enable the BTF support, is not enabled. So I don't have BTF information on this machine. So how can I use BTFHub to run this program on my machine? Okay, so I will go here to the BTFHub repo. Actually, I have that clone on my machine because I don't want to clone this live. So this is just the BTFHub repo. If I check the different sources or the different BTF files available, let me see if there is something available for the kernel version that I'm running right now. So yeah, there is a file available for this kernel version. So yeah, let's use that file. I'm just going to copy that file to a location. Just going to use a shorter path because that's easy to type. So actually, I should use BN Linux. That's better. So yeah, I just put the right file for my specific machine to this location. But yeah, if I try to run again the application, this is not working. Why? Because the application is still trying to look for the BTF information at the well-known location. So what I have to do right now is to modify the application so it looks the BTF information on that file that I just created. So let's do that. Actually, I'm going to copy and paste this line because I always forget the right syntax. Okay, so the first thing that I have to do is to declare an open options. This is a way to tell libbpf some extra options when opening the program. And I'm going to say, okay, there are some open options. This is BTF custom path. Hopefully that's the right name. And this is the path of the file that I just created. And here I only have to change this to say, okay, I want to pass some options and the structure that I want to pass is this one. So if you consider the changes are pretty small, just declaring open option structures, setting the BTF custom path on that structure and pasting that to the open method. So let's see if this is compiling fine. Okay, it seems to be working. So if I try to run again, wow, yeah, we see that this time is working. So somewhere, actually, I don't know. Yeah, it is telling us that it was able to patch the different instructions. So this is what I was telling you before. This was the original offset that the program was trying to access, but by using this BTF information, the BPF was able to understand that the right offset on this machine is this one. So the program was updated. And yeah, it seems like the program is running fine. Just let's check the output of the trace pipe. Yeah, we see that this is printing a PID. And actually we can check that the PID is the one of the minimal program that I was running before. So yeah, this is how we can use BTFHub to run an application on a machine that doesn't provide BTF information. Okay. I think you were asking something about the limitations of BTFHub, right? Yeah.
I mean, presumably if you're distributing something like Inspector Gadget, you would need to kind of add something that says, before we start trying to run this program, you need to go and download the specific kernel file from BTFHub, put it in this place.
Yeah, that's right.
Inspector Gadget will look in this place for the file.
Yeah, that's absolutely right. Actually, there are two different possibilities. The first one is, we could say, okay, let's ship all the BTF files together with our application, but actually it doesn't work. If I try to sum the size of all BTF files on BTFHub, this is something like 5 gigabytes. So of course, this is not possible to ship to use 5 gigabytes only for the BTF information
It's
when,
our lightweight eBPF tool, but it comes with 5 gigabytes of data.
yeah, actually, yeah, when our tool is just 1.6 megabytes. So this is something that doesn't make sense at all.
Yeah.
So yeah, the other alternative that we have is the one that you were mentioning. We can check a runtime, the kernel version that we are running, the distribution that we are running, go to BTFHub repository and fetch the core file. But yeah, this is something that we are actually using on Inspector Gadget. At the beginning, before BTFGen, we say, okay, let's use BTFHub. This is better than nothing, and we choose to use that approach. But I mean, if you are running this on some environments, this could happen that you cannot even reach an external host to download a file. You know, there are egress, security policies, and so on. So yeah, this is something that could not work on many environments.
So to solve that problem of not being able to download or not being able to distribute all of the BTF files and not necessarily being able to download one file at runtime, BTFGen.
Yeah, exactly. So
tell us about what BTFGen does to solve that problem.
Yeah, sure. So let me go back to the slides. So yeah, this is how we use BTFHub. We get the information from the internet and we feed that into the loader library. And yeah, that's just the same. So in the case of BTFGen, what happens is that usually in our programs, we don't access all the kernel types. For instance, the program that I showed you before is only accessing the PID member on a single structure of the kernel. So we don't need the information about all the types of the kernel. We are actually, to make the core logic work, we only need information about the kernel types that our eBPF program is using. So yeah, while experimenting with BTFHub and different ideas, I say, well, why not to create some small BTF files with only the types that are used by our eBPF programs and ship those files together with our application. And this is what BTFGen does. So we take a full BTF file containing all the data types of the kernel. We take some BPF object files, we pass that through BTFGen, and we generate some small files with only the types that are required by those programs. And those files are very small, some kilobytes or even smaller for some cases. And then we can ship those files together with the application. So what it means is that at runtime, we don't need to get those files from the internet. We only need to get those files from the binary itself.
Great. So how do you actually go about generating, or, you know, if I want to generate these minimal BTF files, how do I go about doing that?
Yeah, so I have a demonstration for that. Let me switch back. So let's say that you already have your BPF program. This is just the same as before, no changes there. You have modified your program to use BTFHub, or whether you are telling you already modify your program to load the BTF file for a specific location. So that's all what I have to modify in our program. What we need to do right now is to generate the small BTF file. So let me do that with BPF tool. So we have this min core BTF command under the gen category of BTF tool. And what it needs is the input is the BTF file with information about all kernel types. The output is the place where we want to generate the small file. And these objects are eBPF objects, because actually this is possible to generate a single BTF file for multiple BPF objects. If you have an application when you are using multiple BPF programs that are compiled on different objects, then you can pass all of them together and have a single BTF file with all the types required by all those objects. Right, so let me pass here. Okay, this is not the right path. This is archive. So this is the source file with all the kernel types. I just want to put this on this file. This is not important. And this is the path of my compile BPF program. Of course, I fail and I need to write here min car. Yeah, never happened when I was trying this, but now that I'm live, it happened to me. Right, so this is working. And yeah, before showing you what is inside that file, I would like to show you what is inside the original BTF file. So if I use BTF dump file, let me copy and paste this. Okay, I forgot the BTF.
Yeah.
So we can see here, this is the original BTF file, and we have a lot of different information. Actually, let me count the lines there. So this is something like 200,000 lines. So there is a lot of information there. If we look our generated file, okay, let me do something before. The size of the source file is something about 4 megabytes. So yeah, for a single file, this is not too much. If you want to ship 1,000 of them, that will be actually too much. Okay, let me check the generated file. So this is temp generated. So the generated file for this specific program is only 130 bytes. And let's see what is inside. Dump file, this is something generated. And this is all what we have inside there. So this is the small file that only contains the data types that are used by our eBPF program. So we were only accessing the PID member on the task structure. So we only have that portion of the task structure there. And yeah, we have different type defs because actually PID is not an integer, but it's a type def. There is another type def that finally is an integer. So this is the only information that our program needs to run. So right, I generated my small BTF file. So let me do something. I'm going to remove the previous one, the original one. If I try to run my program again, this is not working because that file was removed. And what I'm going to do here is I'm going to copy the generated file to the path that my program is looking for. So it should be the right path. Let's hope. Yeah. And if I run the application again, this is working. And yeah, actually I can open the trace pipe file. We can see that this is printing the PID, and yeah, this is printing the PID. So what I did here is that I just provided the specific information that my eBPF program needs to run.
Brilliant. We have a question here. Is this tool, and I think the viewer means BPF tool, is it from Linux upstream?
Yeah, BPF tool is developed inside the Linux kernel repository, but actually there is a mirror on the libbpf GitHub organization. So if you want to compile BPF tool, you can just go here and there are some instructions. So you don't have to clone the whole Linux kernel repository because it's pretty big. So you can just clone this repository and you can compile this.
That's great. We also had a comment from Quentin saying that agreeing about the BPF tool sources being in Linux, and also pointing out that the features available from 5.18. And I guess that he means the BTFGen feature, because you've added this.
Yeah, that's right.
Great.
Actually, yeah, this is telling here about the Linux kernel version is a little bit strange because it was implemented on BPF tool that is a tool of user space. So yeah, not sure how the versioning works there.
Oh, that's a great question. Yes, so it might work, for some other set of older kernels or okay.
Yeah.
All right.
Right. So yeah, what I show here is, this is great. I mean, I just did this for a single BTF file, but if you actually want to ship your eBPF program and run that in many different kernel versions, then you will have to make that for all BTFHub BTF files there. So you will have to run this BTF tool, main core BTF for all of them. Then you will have different small file for each distribution, kernel version, and so on. And then you will have to find a way to pack that together with your application.
So what different approaches are there for packaging up the eBPF program plus the set of BTF files that it needs?
Yeah, so this is actually a problem that is not strictly related to BTFGen. I mean, this is like a general problem on computer programming, and this is how to ship static data with a program. So we have explored two different approaches. The first one is to ship that in the container image of the application. So for instance, Inspector Gadget is only designed to be running inside a container. So we put those files directly in the container. So for instance, let me show you. I run this is the container image of Inspector Gadget, and we have the generated BTF files on this folder.
Okay.
So we just generate the files while building the container, and we put all those files inside the container image. And in this case, we have, I hope this is readable, we have some logic here to check if the file for the system that we are running on is available. And if the file is available, we copy that file to a well-known location where different libraries will look for. The advantage of this approach is that in this case, we don't have to modify the applications because libbpf, I mean, the different libraries supporting core look for the BTF information at some well-known locations. So this is one of those locations. So we don't have to modify our application. Actually, yeah, this is a bit of historic here on Inspector Gadget because before we were trying to put the BCC gadgets without any modification. So we didn't want to modify them because, maintaining a modified version is difficult. So we decided to use this approach to just put the file on a very well-known location to avoid modifying the application that we have in Inspector Gadget. So yeah, this is one approach. I think the advantage here is that this is simple. You don't have to modify the applications. You just generate the files and put those files in your container image. But
it looks
of
like
course,
that will fall through if it doesn't have. Well, it looked like its first choice would be to use the BTF information from the kernel if it was in that
absolutely.
location, and then if that doesn't work, it'll try to use a shipped BTF file. And it looks like if that isn't available, maybe you're running on a different distribution, then looks like it's actually going to try and download it from BTFHub. So it's got a few
that's
different
absolutely
backups.
right. So the first option is, of course, if we have the BTF information for the kernel, everything is right. We don't have to do anything. That's fine. Then we try to look for our local generated file. But yeah, it could happen that you are running an old Inspector Gadget version it could happen that when we compile the Inspector Gadget version that you are running in, the BTF information was not available on BTFHub because maybe there was a patch release. So in that case, we say, okay, if this is not available, let's try to see if we can get that from BTFHub. So yeah, we have something like a fallback mechanism. And yeah, actually at the end, it could happen that there is no any option available. And at this point, we fall back to use the BCC tools that are compiled on each target machine.
Okay. Just going back
Right.
to what we were talking about before, Quentin confirmed that what he meant was that you need the kernel source code from 5.18 or above, but once compiled, it can work on older systems as well. So thanks, Quentin, for clarifying that.
Great, thank you. Right. So the other way that we can use to ship these BTF files is to put them together in a binary. So if you are shipping a binary, you are not using any container image, so we can put all of this together with your binary. And this is something that we did for BCC. So we integrated this BTFGen support with the libbpf tools from BCC. And yeah, I just want to show you quickly how it's done because it's a little bit complex. So we have a make file that does almost everything. So in this make file, we have the logic to uncompress the BTF files from BTFHub. And we have the logic to generate the reduce or the small BTF files using a BPF tool. And then what we do is that we take all these generated files, we compress them, and then by using the LD tool, we create an object file that we can later on link together with our application. And yeah, let me show you one of the tools. This is very similar to the sample that I showed you before. So we have here, again, the open options, but we have this helper function that checks if the BTF file for this specific system is available in the binary. And if this is available, this function extracts that file, saves that to a file, and sets this BTF custom path member. We can see this quickly here. So this is the ensure core BTF. We have the same logic that we have in Inspector Gadget. I mean, if the system provides BTF, there is nothing that we should do. We get information about the system that we are running on. We uncompress all the generated BTF files. In this part, we check if the specific file for this system is available. If available, we save that to a file, and then we pass that path to this. So yeah, if you are using libbpf and you want to integrate with BTFGen, I really suggest you to check this implementation in BCC because, I mean, I like this because there is no any script. There is everything is done with a single make file using the implicit roles. So yeah, maybe you can just copy this make file to your application. I think you could also reuse this logic here, and that should be fun for everybody using
And that's in
libbpf.
the libbpf tools
Yeah, that's
part
right.
of BCC, right?
That's right.
Yeah, right.
And yeah, just this is if you are using C and you are using libbpf. If you are using, for instance, Cilion/eBPF library and using Golang, actually in that case is much easier because there are the programming language. I mean, Golang already provides some mechanism to embed those files together with the binary, so you don't have to do this all by hand using make file and so on. So in that case, it's much easier. If you want to check that approach, you should check the Tracy project. This is what they are doing.
Oh, okay, great. So, are there some limitations to what we can do with these BTF generated files?
Yeah, so one of the limitations, the bigger limitation that we have faced is that there are some programs that require the BTF information from the kernel. So there are some new BPF tracing programs, FN3, FLC, also the LSN hooks. In that case, the verifier is smarter and the verifier uses the BTF information to make like a better verification. So there is something like, okay, this program is trying to access this member that is named foo, but this is not allowed to do that. So let's reject this program. So yeah, in few words, the verifier uses BTF information. And in this case, because of security concerns, the BTF information has to come from the kernel itself. So this is not possible to get to give the BTF information from the outside, because we could create a BTF file in a craft way, and we could fake the verifier to do our own verification, and this is something that is not allowed. So using BTFGen, we cannot support Fentry, Fetsy, and other programs.
So
like
it's checking that it's being given the BTF file that was actually shipped with the kernel. How does it tell whether, is it?
This logic is directly in the kernel. So the verifier looks at the kernel BTF information directly.
Okay, and maybe it's checking that file is supposed to be there in that location.
Actually, for performing the core relocation, this is all done in user space. So the file that I'm pasting here is just for the user space library, but the verifier has its own logic to get the BTF information from the kernel.
Okay. Are there any other limitations?
There are other limitations, but I will say that those are not strictly related to BTF, because the general goal here is to run BTF programs on all different kernel versions. But what it happens is that when you start running programs in all versions, there are some features that are not available there. For instance, if you want to use global variables, that's not available in something before like 5.2, I think. So if you take a program that was writing for a newer kernel version and there are global variables there, the program is not going to run on an older kernel version, even if we provide the BTF information with BTFGen, BTFHub, this is not going to run. So the limitation is that you have to be aware of the features that you are using, or better, the features that your program is using, and the features that the kernel where you are trying to run provides. Also, there was something about the Kpro API, that there is like all API to attach Kpro programs. There is a new API, and those are not compatible as far as I understand. But general limitations regarding missing features on older kernels.
So over time, do we expect that kernels are more and more likely to include this BTF information? My guess is yes, because if people want to use fentry, fexit, if they want to use BPF LSM, they're going to need that information. So do you think it's reasonable to assume that we'll increasingly over time see kernels including their own BTF information?
So this is something that we have been doing. We have gone through many different distributions and asked, hey, please enable BTF because we need BTF. There is always the concern, but if we enable BTF, this is going to use, 5 megabytes more. So this is something that Rafael from Aqua Security was doing, especially for Ubuntu. He was like pinging Ubuntu maintainer, hey, I need BTF, I need BTF, I need BTF. I did the same for a couple of different distributions and so on. So currently, I think BTF is enabled on most of the most popular distributions. Actually, if we go here, we can see that this is enabled on Fedora, Red Hat. So this is almost available on all the major distributions right now. Actually, last year, I don't remember, maybe last year, this year, happened something surprising to me, that Ubuntu enabled BTF on older versions. So even if you are running something like 2004 and you upgrade your kernel, you are going to get BTF.
Cool.
This is amazing. We are getting BTF everywhere, and that's great for us and for the whole community.
Thank you to the distribution maintainers who are adding this BTF information.
Yeah, that's great.
So what does that mean the future is for BTFGen?
Well, it means that BTFGen is just a temporary solution for this. We are trying to cover the gap with where we have some Linux distributions without BTF, but now that all Linux distributions are enabled BTF and that the people is upgrading the kernel to those versions with BTF enabled, BTFGen won't be needed anymore. I think there are maybe a couple of years where BTFGen is still useful, but yeah, after we have most of the user running newer kernel versions with BTF enabled, that's it.
So is there anything in this period of time before we hope that BTFGen won't be necessary at all, but is there anything else you'd like to be, are you thinking of enhancing BTFGen in any way, any new features you'd add?
Maybe, I mean, there is this BPF tool common to generate a skeleton from your BPF program. So it generates some structure with the programs, the maps that you are using, and it makes it easier to load the program. Maybe we could consider also generating the BTF information inside the skeleton, but yeah, this is only an idea. I'm not sure if we have the time or if this is something that we should be doing, because anyway, BTFGen is not going to be used in the far future, so probably something that we should not be doing.
Yeah. So we had a few people who had said hello, who I'm going to quickly just bring up. Hi to Tam, who's watching from Australia, so it must be like the middle of the night for you. We've got Ibrahim, who said hello. Hi to Guram, who's watching in Israel. Akhil, who says hello from India. So hi to all of you who've been watching. Great to have you with us. If you are watching and you have questions about BTFGen or anything else you'd like to ask Mauricio or me, then get typing quickly. We only have a few more minutes. We also have, we've seen this person before, and I always fear I'm mispronouncing his name. Bojan Che. I'm probably, I apologize if I've said that really wrong. But anyway, hello all, happy Friday. That's a lovely message to have. So hi. All right. So I know it takes a little while to type questions in. So if anybody does have anything to ask, we'll give you a few more seconds. But meanwhile, Mauricio, is there anything else that you would kind of like to add, or anything else you would say about BTFGen?
Yeah, sure. If you want to know more, please check our blog post. There is a general explanation there of what BTFGen is, how to use BTFGen, and at the end we have different links if you are new to this card terminology, BTF, and so on. So yeah, if you want to understand more about that, I think this blog post is the best place to start.
Great.
I think
And
it seems to be the wrong link. I think the right one is here.
So these are the show notes that you can find on HackMD, which is down that corner. There's a link to our HackMD, and you'll find the blog post is one of the links that we've added. I think also links to BPF tool and many other hopefully useful references, as well as the headlines that we talked about earlier. All right. So with that, I think it probably just remains to say thanks very much, Mauricio, for spending time with us today and explaining BTFGen to us, and for showing it in action. Always great to have live demos. Thank you to everyone who's been watching. Lucas says that is a nice blog post, so congrats. And that seems like a really great note to end our show on today. So Duffy, I believe we'll be back next week. And thanks again, Mauricio, for...
Thank you, Liz, for having me.
All right. Bye, everyone.
Bye-bye.